So my name is Sarah King, and I'm the Team Wildlife Engagement Officer at the Wildlife Trust, but I was a trainee on the Nitrate project. So I'm talking to you today about some of the work I did whilst I was a trainee. So myself and Ian are going to give you a talk on nutrient sampling. So in 2019, when we were first doing the pond survey, it became apparent that quite a lot of the ponds we were sampling had high nutrient levels, and we wanted to do a bit more detailed work on what this was. And we were lucky enough to get support from Birmingham University in doing this sampling. So we'd like to say a big thank you to Professor Sammy Uller and Bethan Davies, who supported us in doing the lab testing and in interpreting the results of the sampling. So we'd also like to thank the project trainees who went out and did the sampling, along with a group of very keen volunteers who joined us over the course of these sampling sessions, and Beth and Ian, who provided the training and sourced the equipment for doing the sampling. So one of the reasons we wanted to look at the nutrient sampling of the Ice Age ponds is because the ponds themselves, as has been mentioned, lie in closed catchments, so they don't have an inflow or an outflow. So if nutrients are being washed into the ponds, they're going to stay there, they're not going to be washed away again. And it has quickly become apparent from field sampling in 2019 that there were high nutrient levels. So I'm now just going to talk a bit about the process, and then Ian is going to run through the results of this sampling with you. Next slide, please. So why do we want to examine the nutrients? Well, high nutrient levels are not good for the ponds. High nutrients lead to eutrophication of the ponds. So that's reduced oxygen within the ponds, which then means it can't support pond life, such as invertebrates or amphibians. And it makes it a much more hostile environment in general. So we don't want ponds to have high nutrient levels. Like I said, in 2019, we did some sampling with field kits of phosphate levels, and we were getting high levels coming out. Quite a lot of them were over 0.5 milligrams per litre, which the Freshwater Habitats Trust guidance says that a good quality pond or good quality water should have less than 0.05. So you can see that there was quite a significant level of pollution in these ponds. So in 2021, we decided to do some sampling across 3 different seasons. So we looked at spring, summer and autumn. We went out in May, July and October to go and sample these ponds. That would give us a bit of an understanding of whether nutrient levels in the ponds vary through seasons. And we also looked at a variety of different land uses surrounding the ponds to try and get an idea of the impact of surrounding land use on these ponds. We were limited to the number of ponds we could survey, so only 20 ponds were included in this sampling. So that does limit the results that we got slightly from these tests. But it's a start, and it's giving us more information because ponds in the past haven't been very well sampled, and the details of the water quality hasn't been well recorded, so we're starting to build up a better idea. It also allowed us to confirm whether the results we were getting from those field tests were actually accurate, and whether they were in line with what actually came out from the lab testing. Next slide, please. Next. So how did we choose the ponds? Like I said, we only had 20 ponds, and as has been mentioned, we found over 600 odd Ice Age ponds across the county, so we had to narrow that down. And some of this was logistics based. So these are the northern section of the area that we did. So there's one up at Berkshire you can just about see, and another cluster down at Staunton-on-Arrow. Next one. And then this was the southern selection, so one up at Norton Cannon, cluster down at Penchester and Cannon Bridge, and then you can see out towards Mockless, Blakemere, and one right the way out to Clifford. Next one, please. So that's an overview of the location of the ponds. And one of the logistical issues was we had to do all of the sampling and get the samples to Birmingham within 48 hours, which it takes a surprising amount of time to sample a pond. So some of this, we did choose them based on how quickly we could sample them all and get those samples up to Birmingham. But we also, as I said, wanted to look at land use. So we considered different sites that had arable land near them, whether they were grazed heavily, whether there was a large wildfowl presence, which in some of the cases there is a large wildfowl presence, as well as the logistics of driving between them. Next slide, please. So these were some of the sites that we visited. As I said, we considered different land uses, and we also need to be able to make contact with the landowners, and the landowners, we'd like to say a big thank you to all the landowners who allowed us to come and sample on your sites. It's been really useful for us to be able to collect this information. And the land use varied across the sites and across the seasons as well. We know in at least one case there was fertiliser spread on one of the fields upon laying, only a couple of days before we did the sampling. In some cases, at one time there was a large number of cattle grazing, and at a different sample point there was no stock in the field at all. And so sampling at 3 different points has kind of given us a range of different experiences of the different land use and the different management of these sites. A couple of the sites were on reserves, so those had a very low intensity of management as well. Next slide, please. So how did we do the sampling? Like I said, Bethany came out and they trained myself, Rose, Kath, and a group of volunteers in how to do the sampling. At each site, we weren't just collecting water samples to go to Birmingham to be sampled. We were also carrying out field tests. So we measured phosphate levels, nitrate levels, pH, electrical conductivity, and water temperature in the field. So we could then compare those to what came back from the labs and see how reliable our tests in the fields were. That was partly why it took so long to complete these tests. And the samples needed to get to Birmingham within that 48-hour period, because the longer you leave it, the harder it is to draw a conclusion as the pollutants break down within the water. It's harder to detect them. Because of this, we did have some absolutely atrocious weather. Next slide, please. This was the end of day 2 of torrential rain. We weren't very impressed by this point. Next slide, please. We also had some very helpful cows. At one point, one of the cows did run off with one of the bags. It wasn't very helpful in the slightest. But luckily, we did manage to get the water before they caused the chaos. Next slide, please. And so, like I said, why are we examining nutrients? So the higher the nutrient levels in the pond, the greater eutrophication is going to occur, and the less oxygen there is in these ponds for wildlife. And so particularly in ponds where there's high nutrient levels, you're going to, if you go for a pond dip, which we're doing in a lot of ponds, you're not going to see the range of diversity that you'll see in a healthy pond where the water quality is good. And what we've noted is ponds don't generally have sewage outlets into them like rivers might suffer from, but because they don't have outlets to wash away these nutrient levels, anything that is going into those soils in the area around the ponds is going to be washed into them during rainfall and isn't going to have a chance to wash away. So in the initial analysis in 2019, as I said, quite a lot of these ponds had greater than 0.5 milligrams per litre of phosphate in them. And that was what triggered us to want to carry out these additional sampling. So the 2021 analysis we looked at in spring, summer and autumn. Unfortunately, although we did try to choose ponds that would have water during all 3 of those periods, they didn't all by the end of it, and a couple of them had such limited water we couldn't collect good enough samples to be able to carry out the tests. But broadly, with the 20 sites, we were able to get 3 samples across the period, which has just given us a bit more confidence in the results and to also monitor how it's changed over that season. So yeah, those were the 3 seasons. Next one. So as well as those field samples that I said, these are what we actually measured in the lab. So we had phosphorus in the form of dissolved phosphate, nitrogen as dissolved nitrate, dissolved organic carbon, which is the portion of organic matter made of small molecules rather than particles, and the total nitrogen. So that's all the nitrogen in a water sample, most of which comes from the organic molecules. And the results were limited, as I said. We could only monitor 20 ponds, and we only had those 3 different periods when we monitored them. But we have been able to draw up the results and have a look at what the impacts of those are. And Ian is now going to take us through those.
Thank you very much, Sarah. I must pay tribute to Sarah and her colleagues. They haven't done any work of this kind before. It is quite demanding and difficult to get things right. There's so many mistakes you can make in this sort of thing. And nutrients are also difficult to analyse. So it's quite a demanding thing to do. And I'm really pleased that the quality of the effort that they put into that. So if we move on to the next slide. And now here we're going to see diagrammatically what the Freshwater Habitats Trust tell us about what corresponds to being polluted. Now there isn't an exact definition of what is a polluted water. Because it depends on what you're using the water for, or what organisms want to do in that water. So it's very difficult to establish. Now, if we look at the upper part of the diagram there, that's showing us phosphate levels, the lower one showing us nitrate levels, and the different colours there, I'm going to use those colours in subsequent diagrams. Those colours are distinguishing between one end, the blue end, no evidence of pollution, through to the red end with very high levels of pollution. And the boundary that the Freshwater Habitats Trust have put on it here between some pollution and high levels of pollution is 0.1 milligrams per litre. And I think they've chosen that because that's a level that the European Environmental Protection Agency and the British government have said is a kind of guideline above which water can be regarded as polluted. But actually, the European Protection Agencies say that if you're going to drink that water, if you water that's going to reservoir, it should be only a quarter as much as that. So you see, it's a movable feast where these boundaries are. For nitrate, they put the boundary at about 1 part per million. That's 1 milligram per litre. But actually, the regulatory limit is 50. And what they're standard by is why is the regulatory limit in both the United States and Europe written 50 milligrams per litre? I mean, that isn't very nice water. And yet, that's the limit because we know it in practice. It's so difficult to keep our waters clean. But this is ideally what the sort of levels we want to get to. Right. So let's move on to the next slide. And I'm going to show you a series of these bar charts, and they're going to be have a similar kind of organisation. So I just need to explain slowly how they work. So the diagram I've just shown you. You go from the blue to the green to the orange to the red. That's the increasing levels of pollution. In the diagrams I'm going to show you on the right, you go up in the diagram. And you can see how the text starts off with blue, no phosphate pollution. Then it goes to green, some phosphorus pollution. And then orange, high level of phosphorus pollution. And then red, very high level of phosphorus pollution. And then along the horizontal axis, we've got the number of ponds which fell within those levels. Now, some of you who like exact numbers will say, well, why don't you give us the exact numbers? And the answer is because this analysis is unnecessarily subject to significant errors. In fact, the laboratory measurements were not as accurate as the field measurements, I don't think. And I've got a few of the laboratory measurements were not determinable for probably more than one reason. So the laboratory measurements are down there in the lower left, field measurements on the upper right. I'm going to stick with the field measurements for phosphorus, but they're showing the same pattern. See, most of the bars in both of those two diagrams are near the top. That means they're in the level or very high level of phosphorus pollution. So that means they're above 0.5 level that we had noticed in the preliminary sampling in 2019. So that's sort of one headline then. Most sites have very high levels of phosphate pollution. And And the second point is that it's something that's persisting through the season. So we've got the different colour bars. The blue bars are May, grey bars are July, the orange bars are October. And there is some difference between the seasons, but not very much. So that's the general headline. Is the bad news in terms of phosphate levels. Now, of course, these ponds do actually have a lot of invertebrates in them. But how much more diverse might they be if we could keep those levels down? But we've got a really major problem here, and it may well be that this is a UK-wide and a European-wide problem too. There actually haven't been a huge number of measurements over the years, although Freshwater Habitats Trust has started some projects in recent years looking at this. But the particular problem you see that we have with our ponds is that they are closed catchments. They don't have streams draining. So where does the pollution go? Now the water, you see, can evaporate into the atmosphere, or it can transpire through plants, or it can sink into the ground. The pollution, that could sink into the ground if the water does. It could be transformed into new organic matter if organisms are growing and be positive. But that's actually, for nitrogen, it can be converted into other forms of nitrogen, as we'll see in a moment. But for phosphorus, it's really difficult to get rid of it. And it turns out that phosphate pollution is the single biggest problem we've got. Next slide. So we're going to move on now to nitrate. Now, the nitrogen cycle is quite complicated. There's a complicated diagram on the left. I'm not going to go into it in detail, but there are different forms of nitrogen, including ammonium and nitrate. And it cycles through the soil, through organisms, through the atmosphere, and so on. It's a bit complicated. What the regulations do is to focus on nitrate. And I think the reason that the regulations were developed in that way is because agriculturally, it's very common, of course, to add potassium nitrate as a fertilizer to the land. And so nitrate is something that we can see being added in large quantities. And so the government guidelines are to try and limit that. And that focus on nitrate reflects that. At the moment, though, there is some interest in ammonia as another issue that needs to be taken into account. Ammonia is circulated, goes into the atmosphere, and back onto the land. But we haven't measured that, and it's something for which there are no regulations at the moment. So nitrate, let's see how that plays out in the next slide, which is to do with nitrate vulnerable zones. So the way the legislation works then is, which you have to be very aware of if you are a farmer, is that if you're in a nitrate vulnerable zone, there are certain things you can't do. And those dark purple areas there are the nitrate vulnerable zones, and nearly all of our ponds are in nitrate vulnerable zones. So if you click on one, Dave, then there should be some more text appearing. There we are. So things you can't do is to put nitrogen fertilizer within 2 meters of a surface water or hedge, and you can't put organic manure within 50 meters of a spring or well or 10 meters of surface water. So, as far as I can see, this is what farmers are doing in this area, and because they're doing that, that is limiting the amount of nitrate pollution. And then we're going to come on and see some good news in a minute. Next slide. There we are. So this is the equivalent diagram to what we were looking at for phosphate. And there on the upper right, that's the equivalent diagram there, going from bottom to top with no pollution to very high levels of pollution. And the boundaries correspond to the numbers of the diagram on the lower right. So the headline, so the nitrate, where does the nitrate come from? So clearly, potassium nitrate fertilizer would be one source, but also when organic matter decays, produces ammonium. Ammonium can oxidize to nitrate. Feces from animals, include urea, that can be converted to nitrate. So there are different sources of nitrate, But the good news is that we're seeing a lot of values which show no pollution or some pollution, and very few which show a very high level of pollution. So that's actually that's in comparison with the use of phosphate, that's really good. These are actually all based on laboratory analysis, because our field measurements, they just didn't work. So here is where and by the way, the need to get to these samples to the lab within 48 hours is because they microbes can grow in water and change the concentrations of things. So that logistics was necessary to have more confidence in the numbers that we've got. So, so a small number of sites are highly polluted for nitrate. And what we could do, of course, is to go back and sort of look at those sites and see if there's anything distinctive about them, and just test that with it. But it's not a problem for preventing sites. Where we are seeing more pollution, it's more pronounced in July. So there's that grey bar that you can see, which is very long under the sun nitrogen pollution. So July tends to be a bit worse, but it's not reaching those very high levels. Another thing we did was to see, are the sites with more nitrate pollution also the sites with high phosphate pollution? And the answer is there isn't a link between the two. They seem to be separate issues. Next slide. Now, the third, another thing that was measured is the dissolved organic carbon. And this is basically the carbon that's present in small organic molecules that are dissolved in the water. And this is quite a good indication of how much material is available for to be metabolized by bacteria or even by process that material. Now here there isn't actually a standard to say whether something is polluted or not. So all I've done is to take the range of readings we've got and I've lined them up. I've grouped them into 4 categories, you can see, between 0, 10, 20, 30, and above 30. And then we see the distribution like that. And there is quite a range, but there are very few sites which have little dissolved organic carbon. So it is pretty universal that we have a significant amount of organic carbon. And it mostly, the highest levels we see, the more points we've got, the longest bar that we've got at the top of the diagram is in July. So that's when there's a lot of metabolic activity going on in the height of the summer. And what we might anticipate is that during the winter, this dissolved organic carbon will go out of the water column. It will tend to be taken up by microbes, and it can also attach itself to particles and then be deposited as a sediment at the bottom. So that's more likely to happen over winter when there's so much activity by higher organisms. So that's giving us some feel for that, and people who work in this field use this parameter quite a bit. Next slide, please. And the other thing that we were recommended to analyse by Sally Buller at Birmingham University, who incidentally is on the DEFRA advisory panel for looking at he said look at total nitrogen. And this is like the previous parameter, total nitrogen is something that's where the measurements look pretty good. They're very precise measurements, actually. More confidence in the exact numbers with this than we do for nitrogen. And this nitrogen is mostly actually an organic matter. So although we're measuring nitrate and the regulations are about nitrate, that's just free molecules, sort of free ions of nitrate. Most of the nitrogen is actually in the organic matter. So it's sort of in that dissolved organic matter in the water. And we look at that, it's a bit more complicated here because there are more sites that have very little of this material, whereas there are quite a few that have rather a lot. And May is the month when there is least of this material around. So we have least dissolved organic carbon with nitrogen. And DEFRA does, there's not a strict regulation about this, but DEFRA does have an aspiration to limit the levels to 3 milligrams per litre. And that is an impossible aspiration. It's just not going to work based on typical field conditions. The next slide. Now then, we're going to follow through the season and summarise what's happened through the season. So let's go to May to start with. So May has got lower levels of dissolved organic carbon and organic nitrogen, and some sites have little phosphate pollution. However, most of the sites, as we've seen, have got these high phosphorus levels. And over winter, organic matter will decay, and in particular, one thing we have to bear in mind is that when you get a lot of runoff during fields in winter, that's going to bring particles into the ponds. And particles generally have a lot of phosphorus and nitrogen adhering to them. That's historic pollution that's been trapped in the soil over decades. When, in earlier decades, there was more extensive use of fertilizers before more regulations came in. And this stuff is still sitting around in the and so that's likely to be an issue in terms of releasing the next slide. Sorry, yeah, next one. So in July, then this is when our osmotic activity is at its peak. The nitrogen builds up at this point, and the amount of dissolved organic carbon is high. So if you had a situation where there was lots of fertilizer around, then those effects would be there as well. Next one takes us to October. Things are starting to die down now in terms of the dissolved organic material, but phosphate is still very high. And then the next one takes us over the winter to May again. So over the winter, then we're not losing the phosphate from the water. It's difficult to get rid of it. That's the thing that comes out of this. Whereas the dissolved organic carbon does not. Next slide. Relationships with land use. Then on the upper left, we've got the amount of phosphorus. I haven't coloured it, but it works in the same way. So more pollution is at the top. So in arable sites, like this one at the upper right there, we're tending to get relatively high levels of phosphorus. And in the pasture that's heavily grazed, we're also getting quite high levels of phosphorus. But we've seen that it's typical for most sites. So with this land use, we haven't got any low phosphate. Next one is showing us a situation where we get lightly grazed pasture or actual nature reserves. And in those cases, we do get some observations which have got low phosphate. But even in these situations, we're still getting many sites with high phosphate. So even when we can absolutely put our hand in our heart and say there is no pollution being added at the moment, there's still a lot of phosphate there. So I suggested that we, instead of talking about phosphate pollution, which is an emotive term, implying that someone's done something wrong now, that we talk about excess phosphate. So there could be things that have happened a long time ago that are still having an effect on these actions. Next slide. And then, sorry, this is now nitrogen as opposed to phosphate. And again, most of as we saw earlier on with the nitrogen charts, most of the points are near the bars are near the bottom of the diagram, so there's not much pollution. There's no difference between the lightly heavily grazed sites actually for nitrate. And one more slide here, I think. Yeah, here we are. And so reserves and arable land are generally pretty good for nitrate, except at slightly higher values in general. So next slide. So we're going to bring up our conclusions, and one by one. Here we go. So going back again to the that geological definition of ice age ponds. They're what I call closed catchment. The water can't escape its streams at the surface. And that means they tend to trap nutrients. They trap pollutants. Next slide, please. Showing us the next conclusion. There it is. So we've got this big problem with excess phosphate. And that phosphorus could have hung around for ages. It could be attached to particles on the soil. And if you have bare soil and you have winter eroding particles of that soil, that could be one way in which phosphorus gets into. Next slide, please. So the story with nitrogen is more favourable. In the nitrate levels are not so much concern. DEFRA at the moment are worrying about ammonia. There's lots of chicken waste in the Y catchment, as we know, and some of the that produces ammonia, and the ammonia goes into the atmosphere. So there's an atmospheric nitrogen loading as well, which we have measured, and which DEFRA is trying to get its head around. But it seems as though, if that is an issue with ammonia from chicken plants going across the Y valley, it isn't causing nitrate emissions. Eventually, that ammonia will oxidize to nitrate. So at the moment, I don't think it's something we need to worry about, but it's something that we're looking at. One more thing. So, in other words, you could have a landowner doing their best, obeying all the regulations, doing everything right, and yet we've still got this big phosphorus pollution. So I think, so in other words, if we talk with landowners, then all we can say really is redouble your efforts about not grazing livestock close to ponds, and look at the vegetation cover. Cover crops are great because they reduce runoff and reduce erosion and so on. So those are some practical measures that can be taken. But there's a lot we don't know. There's a lot that could be done to actually look at where the nitrogen and phosphorus is and in what forms it is in these catchments. And it's really quite an under-researched area. But at least what we've been able to do is to sort of throw a light on what some of the main issues may be. Thank you very much.